and welcome to our training for SkylineGlobe Server. For anybody who wants to know how to use SkylineGlobe Server, how to install it, configure it, use it, and in different architectures, in different use cases, and using different data, clients, different systems that we'll install on. We'll do a full review of what SkylineGlobe Server is. So my name is Eilon. This is the product architecture from SkylineGlobe, our entire product set that is a full end-to-end 3D solution from the production of data, actually all the way from the capture of data to the processing of it, making it usable and distributable into a 3D form that is web shareable and consumable by all different clients, internal and external, proprietary and public, open source, in a way that you can take 3D data of different types, features, imagery, LiDAR, CAD, point clouds, all the types of collects that you can get from different sources of things that are in the world, things that are geospatial, through the different sets of processing tools, the building tools like PhotoMesh, TerraBuilder, and TerraExplorer that are that build the 3D scene from the sources. If it's standard GIS data like feature layers, point cloud models, and so on, they're loaded to the scene. If there are data sets that needs to be processed into a 3D scene, like when you collect photos from a drone or from a manned aerial vehicle, you have PhotoMesh that will build that into a 3D textured mesh. All this is part of our building tools that we won't talk about too much. And all the way to analyze them in, analyze the 3D view and analyze the 3D in any number of client applications, including TerraExplorer Desktop, Fusion, Mobile, our developer packs, and any other external client, and we will stress the interoperability. So what we will focus on in this webinar, in this demonstration, is the sharing, the SkylineGlobe server. SkylineGlobe server is part of the suite, part of the flow of an end-to-end solution, where data from our building tools get published onto it and then consumed or served into the client applications. So the same data sets and types that were captured in one way or another, processed by the respective processing tool, are then being put on the server, and they are managed there, and they are served from there, and they are consumed or put in a way that allows them to be consumed and streamed very efficiently by the different clients. So we're gonna focus on the sharing. So SkylineGlobe server in general, securely, with a focus on security, stores and accesses 3D geospatial data where, when, and how you need it. It's a private cloud. That's the easiest way to think about it. Private cloud solution, and by private cloud, it means that it can be deployed on a full, robust AWS cross the globe system, or on a single laptop that has SkylineGlobe server installed on it, like I will be doing here on a small VM. And the same software can run anywhere from a very localized single instance server or computer, all the way to a full robust implementation, and we will talk about that and consider it. And this is why we call it a private cloud that provides comprehensive set of web services for publishing, storing, managing, and streaming 2D and 3D geospatial content. All your GIS layers, 3D mesh, imagery, elevation, features, and point cloud data, as we can see here, can be on your on-premise SkylineGlobe server, on the cloud, or hosted, and then sent to our clients. And we'll talk about that quite in detail, about the interoperability and how the same data, we call it store once, read many. We store it once, and then If it's a Skyline client, then it reads it in one way. If it's an open source Cesium JS client, then we would convert on the fly and expose the same data set as Cesium ready. And same goes for other industry standards, both open source and proprietary. So this is what SkylineGlobe is in a nutshell. What we will cover today, the agenda, we will start with the foundation. We'll talk about how to install SkylineGlobe server, give some emphasis on how it should be installed, points to consider, hardware considerations, and other infrastructure considerations. We will then configure it. So the nice thing about SkylineGlobe server, as said before, that it can run on a small laptop in field inside a military operation or inside a construction site, and also can be installed on the back end, on server farms, and so on. But the installation of it is something very simple, at least in the basic configuration. It's yet another next wizard that we go through. And for simple configuration, it's not that hard to get a server going. So it's not like I need to install a server, I need to install Oracle. It's just a simple Windows application based on IIS that is quite easy to install. Still, we will address the points that we need to consider in installing it. And then how to manage it. There are many things that one can do, from a very simple install and use all the way to extracting more value from the solution. So that would be on our foundation. The usage is more to the, okay, once I have installed, or our IT, our backend folks have installed and configured it, now I'm a user. So I don't care about how to install SkylineGlobe server. I'm given account on a SkylineGlobe server that is installed on my organization. And also Skyline offers a hosted SkylineGlobe server. So you can come to our people, request a hosted account for SkylineGlobe server with so-and-so user and so-and-so storage space and so on. And you will simply get access to a SkylineGlobe server that is installed on our secured AWS infrastructure. And you can start interacting with it. And it is actually built in a subtenant way, meaning we have a big SkylineGlobe server, but you can own a part of it, which is completely isolated, and you get your own space within that SkylineGlobe server that is completely in a compartment for all the rest. And it would be your data and only your users and so on. So you would be focusing on that part. Once I have SkylineGlobe server installed, how do I use it? And that includes mainly publishing data to it. So I'm the editor, I create the data, I want to share the data with my audience. We will talk about different ways to publish into it. We'll talk about interoperability mainly in how to share the data with different types of clients, like we already discussed a bit earlier. And then optimizations. So things work very well out of the box, but there's always a little tune-ups that we can do to make the data perform better for different types of data sets, different types of audiences, different types of bandwidth and networks, and so on. In the last part, we'll actually go over advanced topics. So on the first run, I will go through really the basic installations, and then you'll see these stars on the topics that I will go over. So we'll talk about installation, and I'll say we'll talk about the simple installation. But later we will talk about cluster installation of multiple servers running on multiple computers, connected by a load balancer with a backend of organizational database like Postgres or others. So at first part, we will go over the simple flows, and then we'll come back to them. And for each simple flow that can be expanded upon, we will explain the advanced topics like clustering, like using databases, like installing on other OSs like Linux, talking about security topics in unsecured networks, APIs, and troubleshooting. So that would be our agenda for today. Just to go over some of the main features. So SkylineGlobe Server offers the data management. It's a data catalog that allows you to store all your geospatial data, know its properties, attributes, size, type, date, metadata, coordinate systems, and so on. You can then perform geospatial queries on it. Let's find all the data sets that I have viewing access to and are in a certain geographic region, and that are categorized into a certain category or anything like that. So that would be on the data management. We'll talk about the deployment, that it's deployable to on-premise or cloud deployment. The multi-tenant, so what I said about SkylineGlobe Server, our cloud, Skyline Cloud, which is our commercial offering that one can get an account on a fully managed SkylineGlobe Server. In a similar way, when you install SkylineGlobe Server on-prem in your organization, you can yourself split it into multi-tenant. So let's say you're a city, a community, and you can install SkylineGlobe Server and then have your people from the city planning have one tenant, and the people from the security have another tenant, another sub-site, and the people from maybe gardening and waste disposal have another one. So you can always split your server into multiple sub-sites that are, as I said before, in compartments and separated from each other. Scalability and elasticity, it's more on the advanced topics of how you can grow and even grow with demand. So you can create solutions on different cloud environments where when a lot of people are pulling data from your server, more compute resources, more computers would be pulled in and used to serve that load. And when the bandwidth drops and the number of concurrent users drop, you can lower the consumption of compute and your costs accordingly. And we will talk about data security in how one connects to the data, how is authenticated and identified as a certain user, whether you can use different identity providers like your organizational 365 or Google or Cognito or any type of identity providers, and then assign based on that user roles, groups, permissions to different data sets, and so on. So some of the main features. So here's in the green in the center, here's where SkylineGlobe Server's place in the set is. It starts from getting data from the clients, right? The TRX stores and the different viewers and edit annotators push data to it. And on it, we see the silos of functionalities that it has. So it has the upload service that allows it to receive data, and then it stores it, different types of data sets. It has the storage itself where you can host on disk, on NASes, on different types of solutions, all the way to the more advanced storage types later. It also manages the users, the catalog of layers. You can get reports of usage and errors and issues, and of course, administrate it in a similar way. These are the data types that are stored. So we have the point clouds and the maps, which are the raster layers, imagery and elevation. We have the features, including the WFS, is OGC standard for Web Feature Service, and the transactional version of it. So one can connect to the server and load the layer of all the cities somewhere, and then also edit it to update the position, update an attribute value, create a new entry, delete, and so on. So this is the transactional part of it. And then we have the 3D mesh, which is a textured mesh that we will see later on in a demonstration, and the base terrain, which is the imagery and elevation that are the ground itself, plus the project itself. So I want to take a project that has this terrain, this mesh, these layers, this point cloud, and read it as a workspace. Then from SkylineGlobe server, we actually extract the data, we stream it out. We use the stream because just like when you watch an online movie, you get a stream of frame by frame. In here, when one navigates in the 3D world, based on its position and location, the correct subset of the data is streamed into the client, being the desktop or the mobile or the web. Still, based on the type of data, when I zoom on to Las Vegas, this is where the imagery and the mesh and the point cloud and the features for just that area would stream in, even though the server itself has everything or the entire area. Just a specific area when I'm zoomed into would be streamed in. So it serves the different types of data sets that we saw here in 5 main services. The base terrain is served as a terrain service. The maps are just 2D raster images, imagery and elevation that can be consumed by our viewers, but also by other clients, for example, your QGIS or your ESRI or your hexagon tools, anything that supports the public open source WMS and WMTS protocols, we stream the data out. And essentially the terrain, which is built from both imagery and elevation, is consumed or served out as the 2 different channels. So I can have a terrain with both imagery and elevation, but when a legacy 2D viewer reads that data, it will just extract the 2D view of it. For feature service, we have the WFS, WFST, KML. We have for the 3D mesh service, this is actually a very nice one because there are different types of clients that read the data and different protocols and formats. So we store the data, as said before, as one format, but then when Cesium clients consume it, they will get it as 3D Taj, which is the open source standard. Unity and Unreal Engine would also consume it as that. And then if an Esri client is reading it, it would automatically be converted to the equivalent, the I3S or SLPK protocol. Same goes for point cloud, where we have our own compressed point cloud format. And then if anybody else wants to consume it, it is streamed out as 3D tiles with PNTS datasets. Web catalog, we discussed about it. Publishing using TerraXplorer Pro is one of the main ways to publish that we will go over. Server-side scanning is the other, and we will demonstrate it. And you can also use REST API to connect to the server and populate fields, edit fields, query, and so on. When you do a business-to-business or a server-to-server solution and want to automate interactions with the server. We talked about these essentially. So just to do some of the name dropping of the different solutions that, or different clients that can read our data. We will go into the foundation. The first step we will start with is the installation. The installation itself is pretty straightforward. As said before, it's not as difficult as installing a robust server that needs, a lot of know-how. It's pretty straightforward. The steps themselves have certain prerequisites of what needs to be installed on your Windows. It is pretty straightforward. For the purpose of this demonstration, I took a simple virtual machine with a Windows server, and within about 10 minutes, including waiting for the installation to run, I have a SkylineGlobe server configured on it. I will show you some of the steps I did, and some of them I will illustrate using this guide. So once you go through the making sure your Windows has everything that's needed, essentially running some components, we recommend, and a lot of what I will show you here today is actually taken out of our knowledge base. And that knowledge base has a lot of topics. You're actually seeing the internal view right now. So in the knowledge base, we have different articles and links to everything you need to know while installing. And once I have like the right computer, and in this case, we're using Windows Server, that's the recommendation, especially if you want to run multiple clients. But if you just want to have like SkylineGlobe Server serving a few computers around you and so on, you can also go with a standard Windows Professional like 11 or 10 and install it there. So I will be discussing and talking about Windows Server. It is recommended, but not a must. Other than that, we're pretty much going through a next wizard kind of installation. We get the installation, we get the license file, and this is an important part. We will here, as I said, at first we'll talk about the simple flow. So on the simple flow, I'm just creating a new database, and this is not something scary or alarming. It on a simple flow just creates a small file that is served as a database. Everything is local on your hard disk, and you don't need to worry about consumer grade or an organizational database like a Postgres. It just creates a very simple database on your server. This would be the point, however, where we'll talk later about clusters and so on, of how we can create a more failover redundant system that can run with multiple computers at the same time. That would be part of the same cluster. So the installation would be simple in that will use the new database and just a path on our disk. And we would need access to the system resources. So the server itself, the service, needs to read files and store files on your operating system. For that, you would need some kind of a security, like the user, just like the user that you use to connect to the computer. In most cases, if you have the IT to support it, they will tell you which to use. But other than that, you just use the custom account. And I use the same user that I have on my computer that can connect to all the resources. And that's pretty straightforward. And then the rest is really next. It installs the data. For a bit more advanced, it's actually using the inside the Windows world. We'll talk later about the Linux world. It is using the IIS, which is the Windows web server, built-in web server, Internet Information Services. And it installs into that and relies on its functionality. So if I look at the SkylineGlobe server that I installed here on my local IP somewhere, when I go to that root of that is just your normal IIS there, and we installed into the /sg the SkylineGlobe server manager that we would go over in the next steps. So installation is pretty straightforward. There are some post-installation procedures that we will cover as needed, but most of them are not compulsory. So we went through the installation later, which is built for Windows Server and IIS, Internet Information Services. Later, we will talk about Linux and what is different there and unique there. The public URL is probably one of the first things you want to set. The idea of the public URL is that the server needs to know how it is accessed. Because in simple configuration, like mine, I have the server running on a local computer here in the network. And I can access it by its IP inside my local network. But in a bit more expanded scenario, then it could be that your server is running inside a data center and it is actually being accessed from the outside through a load balancer, through a proxy, through some kind of naming services and so on. So you do need, after you have installed the server, to set this property of the public URL. And that's like the first thing that happens. In my case, it was very simple. I installed it. I changed this to the local host, which is the name here. But a better alternative in here would be to change it to the IP that is actually accessed by. So localhost would only work from that specific computer. But once I change it into this, then any client inside my network which could access this IP can now access my server and know everything to know about it. Once I made this change, I can click save, and now my public IP is configured. We'll talk about more settings in the configuration, but I'm going through the basic flow of we went through the install steps, we configured this public URL, and essentially we are good to go. Good to go in the sense that you can see that I am consuming this data as HTTP address. It's not secured. It's very good for local internal networks. Once you want to go into the public world, you do need to use secured protocols called HTTPS. And for that, you need security certificates and so on. So we will discuss in the advanced steps how to use or how to apply different types of certificates, starting from a full-blown administration of certificates that are purchased from a certification authority, but also with small solutions for local usage on your own networks. So that would be this and how to handle unsecured. The single versus cluster is when we said we installed and I installed a very simple installation. I used the option that we saw here for just a local database. And the result of that, when I look at my server, is that I have here under the C SkylineGlobe server configuration folder, which is the default setting, I have a bunch of small databases. You see very small files and some folders that would store the data. And this is where all the data that would be published into the server would be stored on. And this is where the configuration database for SkylineGlobe server would be hosted on. And this is why it is so easy to install a local portable SkylineGlobe server. It doesn't need to carry a big, complicated database with it. And then on the management database, we will explore and let you know that at this point of installation, we need to figure out whether we want to go with a very simple flow, local database, file-based on your local OS, or to store it on PostgreSQL that is provided to you by the organization or that you quickly install. It's also not very, doesn't require high competency to install SkylineGlobe server on Postgres and to install Postgres itself. So this is the installation. And all I did is I ran through the next. I got a server up and running, and I could access it either from that computer on the local address or from my computer over here when I install it and access it from here. So the management database, once I installed it, I don't really need to log into the computer anymore and do a remote desktop or something like I'm doing right now. I access the server from this SkylineGlobe Server Manager, and in it, I can set everything I need, and we will go over these in this part right now, which is discussing the configuration of the SkylineGlobe server. Configuration of the SkylineGlobe server, these are the main things that are worth highlighting. Again, when we go to, and I invite you to do that, to go to support.skylinesoft.com, that's our knowledge base. If you go into the SkylineGlobe server, you can find very clear documentation and tutorials on how to get started, all the way from how to install these articles that we're going through, including managing data sets and so on. Another good resource here is the video tutorials, which are already there, and actually maybe we'll find this tutorial stored here one day, so we're doing a loop. And in here you can see some videos built in. We'll actually go over some of them in a bit when we cover different solutions. And in here there's also the user guide with the full user documentation, where I'm also using in some of this demonstration. But this really gives you every piece of information on how to do any specific functionality that you may want. So we will start with the settings over here and go over some of the main settings in SkylineGlobe server, the ones that are worth mentioning. If you don't do any of this and just go with the default of the public URL, things would work. But still, some of them that are worth mentioning is the name, the title, whether we're doing authorization with like the built-in system of users and groups, or we can connect it to an external system like an IDP, an identity provider of the organization. It can come in different languages. Let's see, I can purge some cache and clear some data on the server. When one connects through WMS or WFS, there are some settings to be used there, like the compression and so on. An advanced topic called Direct Connect that we will talk about has its own settings. This is where the data is stored. We just saw that path on our disk a little while ago. There's also a way here to generate a database token. And if we're here and we're going over the basic settings, that's actually worthwhile looking at, because that maintains a key that if anything happens to your system, it would be easy to port it. So I would definitely recommend generating a token here. It cancels previous tokens, so don't be alarmed by the red. You generate, you take this key, you store it somewhere safe, and if all goes well, you'll never need it again, but it's a good thing to have. So these are all the settings that I would put special attention on, at least on a high level. Once I have this going, I have the data sources. So the data sources are the types of repositories from which I could read data into SkylineGlobe server. Read data that is access data that is somewhere on my server side or on my backend, and expose it to the outside. There are different types of data sources. Let's take a quick look. So I go to the data sources, and in here I have one default data source that is created with the server. It's called the uploads. This is where all data that would be published from the client side into the server side using KR Explorer or other publishing tools, it would be stored here. So if I have already, and I'm jumping ahead for a second, I have already published some layers into this SkylineGlobe server. They have been published to the default upload data source, which is essentially just a folder on the disk on the server side. If I hop over to the server side and look at this uploads folder, you see it has different sites. Again, skipping ahead for something we'll see later, but the default publisher has put data into this server with some naming conventions and GUIDs, GUIDs, and I will find the data there. But essentially, it doesn't matter much to the user because he will be using the publishing tools, connect to the server, and I will show you how to do that. The data would be pushed from the client to the server, just like when you use a video editing software that publishes it directly to YouTube. And the reason why I am pointing this to you is that you need to make sure that these folders are on disks that can support the size requirements that you have for the data that you expect to publish and the I/O. So when we go to advanced solutions and when there are many users reading a lot of data at the same time, then these storages, these disks, should be able to support the required I/O, and we'll have a section about performance a little later on. So this is the first and the most straightforward data source. Other types of data sources could be of this type. So this was of type SG scanner. Oh, sorry, SG upload. An SG scanner would be a data source that reads files from the disk and automatically adds them as layers. So I want to demonstrate that, and I will do that in just a second. I need to switch a site. Go over some of the others that I won't demonstrate right now, but if I have an organizational Oracle, Postgres, Microsoft SQL, or ArcSDE server, legacy SDE, then I can select Oracle server, give the credentials to access it, and then SkylineGlobe server would be actually like a proxy. So clients would connect to SkylineGlobe server, would see all the layers that are actually part of the Oracle database or the SQL database, and be able to stream data from it. So they would be making requests from SkylineGlobe server, which would pass the request back to the server, the Oracle or the SQL or whatever, and pass the SkylineGlobe server would then stream the reply back to the client. So you can have a big repository of organizational databases of different sorts that require robust clients, like installation of a client on the client side so one can connect to it, and maybe very strict security settings for that. In this case, you could just take some of the layers from your organizational databases and expose them. Once I connect it to a server and I go ahead and scan it, I will just be able to import the layers from it into the layers of my site. To show you the other types of databases, again, I'm on the data sources. I'm skipping ahead for a second. And remember how we said earlier that we can have multiple sites under the SkylineGlobe server. So this is the SkylineGlobe server. I'm actually managing the default site right now. But I have another site here, site A. This is what we said before, that if I'm, say, security organization, I can have one group of intelligence user and one group of combatants and one group of logistics, and each of them can have their own subsite, their own subdivided portion. So I created this subsite, and one can manage it specifically. So I'm going to switch to manage this site. Then when I switch to data sources, we see the same upload storage that goes to the uploads of site A that we saw before. And we also have a SG scanner. So this is the type of data source that we have seen before, where we said there's an SG scanner. And what this does is it also points to a storage folder on the disk, in this case, C site A scanner, which has a bunch of data sets. Let's look at this on the server side. This is the server, and this is its disk. Its disk. I scan. Okay, it's actually open. Oh, sorry. There's another one inside the virtual machine without inside a virtual machine. Okay, then we got there. So in this path of the C drive, there are actually a bunch of files here, an MPT, which is our terrain database, some photo mesh results, 3D MLs, mesh layers, some feature layers, and so on. There are files, different types of geospatial files. Because they are put into that folder, and I have defined a data source that is an SG scanner that looks into there, I can scan the layers that are there. It will now read all the files from the disk and identify, hey, here's a shape file that I can expose as a feature layer. Here's a mesh layer that I can expose as a mesh layer. It would also identify that I have already, before this, when I configured this data set, I already scanned some of the data sets. So the MPT and the point cloud and this shape file was already streamed in and cataloged. If later somebody add these layers to the disk, all I need to do is to rescan, and they will also get added to my layers. In fact, when I look here at the properties, I can do an auto scan, and every few minutes it will rescan, and then all I need to do is for a person or an automated system to drop files in this folder, and it would read the files from there. So this is the site scanner, and you can see that all the layers that I have scanned into it are now existing as layers in this site A, that one can consume. So this was the data sources. Then I have users and groups. Inside my site, let's go back to the default site. I can have different types of users. Each user has a role. A super administrator is the one that can access or manage all sites in this SkylineGlobe server. And a publisher is one that can publish data. A viewer can only view it. I can create as many users as I want of the different types. I can even limit their expiration, their roles, what sites they're part of, define their password, limit the amount of storage that they can use or how many, active sessions they can connect to. And I can also group the users in groups and give special groups with different permissions also for the storage and for the sessions and also for access data. So once I have organized my users in groups and in users, I can give access to different layers to nobody, to only me, to my group, my site, everyone, or a selected list of very specific sites and users. So that really gives us full control over the hierarchy of accessibility. There's a SkylineGlobe server. Within it, there are sites, which are compartments, isolated portions of a subsite. Inside of it, I have the users of different roles, and they are inside groups. So even inside my intelligence subsite, I could have people with different classification or different geographic regions that each of them or each group would have different access permissions to different data sets in the server and different permissions as far as how much data they can store on the server and so on. So this is how everything is grouped inside users and groups, mainly for organization and for being able to know to provide the right audience with the right data. In addition to that is the categories mechanism, where once you start having a lot of layers, and you can see this girl is very confused by so much data. This is really hard. So this is actually a later addition. We can put each layer in a category, which allows you, just like in your file system, here's the relief. So you can group the different layers in different categories to better organize them. And the thing is that once you have cataloged all your layers in SkylineGlobe server, and here we only have a small list, you can really do advanced searches and look geographically for all the data that have so-and-so of type so-and-so. And the same queries can actually be done from the client side, not only from the management portion over here, but also from Terra Explorer or other clients that consume the data. So this is here on the categories and sites that we have already discussed. Another thing which is a bit advanced but worth mentioning is the Fusion configuration. Terra Explorer Fusion is the web client that is actually part of SkylineGlobe server. So once you have installed SkylineGlobe server and populated it with data, one can consume the data with Terra Explorer, a desktop tool, or different open source and proprietary clients, and also with our web clients, which is called Terra Explorer Fusion. It's a very powerful in-browser, no installation 3D viewer. And inside the settings page, you can actually do different configurations for the Terra Explorer Fusion. For example, running some scripts at the beginning, logging in as certain users, perform a customization of the user interface, so things like allowing you to control the colors and look and feel of the server. This without really needing to do any real coding, just like very light scripting that says, don't show this logo, use orange color, and so on. So with very light scripts, you can customize the viewer. So I did want to mention that inside the settings page, we have the configure your Fusion is part of that. Identity providers, more advanced topics that we'll go over in the next run. So we have configured the service. It is ready to run essentially after we've installed and configured. We can do different managements that we may need and may not. One is monitoring. So monitoring is simply knowing what's the state of your server. How many users are reading it right now, how many are connected, how many, whether there are any errors, which services I can activate and deactivate some of the services. If I'm running in a cluster, I can have multiple fuses or multiple instances and control each of them. So this of monitoring and getting reports to know exactly how many users have connected, in how much storage have they used, and so on. All these are accessible from the management tools over here. Sorry, over. Find it eventually. This one. So this is my server. This is on the main page. Currently, you see I don't have too much activities. I can get the messages and get different information of errors and warnings and so on that have happened. Not much for now. And I can also access the full help documentation on-prem where I've installed the server. More advanced management can be done using the API. Again, we'll talk about it if needed, but you can have your server installed, configured on a very high level with minimal management, and you have everything working. So we have completed the foundation stage. Next, we will talk about usage. The first thing I want to do is to get some data on the server, right? So we want to talk about server-side publishing. Server-side publishing is actually exactly what I have demonstrated in using data source, configuring it and pointing it to either a folder on my disk or to one of the organizational database like Oracle, SQL, and so on, and reading layers from it. So that would be one way, more of a structured organizational way for organizations that already have the data cataloged in different types of database systems, or a folder on the disk or on your NAS, on your shared storage, where people in the organization drop data, and using this technique that we have demonstrated of using the data source. Let's go again to site A. We have the data source that is just a scanner from a folder on the disk. And at every time, I can go ahead and scan and see if there's new layers. Currently, all of them are already published. So this is what we refer to by server-side publishing. I take data that is exposed internally in folders and databases on my backend, on my back office, and I make them available via SkylineGlobe server as layers that can be consumed by the different clients. So this is what we refer to by the publishing server side. The publishing client side is a very cool feature because anybody that has access to your server and has the publishing credentials that we have given them in the users could open one of our tools. For example, run TerraExport. Now, this is a VM, so don't mind the performance here, but I have TerraExpo, which is our 3D viewer, that is actually loaded with a bunch of data sets, a mesh layer and a feature layer of polygons and polylines and imagery layers and even a point cloud. You go here and you connect to a database. So I'm currently connected to my local SkylineGlobe server as the user default publisher that I've created. I open this data with files coming from my disk. So wherever I am, as long as I can connect to the server, if I take a file that is somewhere here on this machine or this path, a file on my disk, once I've connected to the server and I have TerraExport Pro, which is our publisher, I click Publish to SG, and then it will go over all the data sets. And when I click Publish, it will actually copy the data onto the server. In this case, I've already done that. So it actually tells me, listen, this 3DML, this file on the disk, this TIFF file, this point cloud, you've already published it before. Are you sure you want to publish it again or just reuse it? So I will reuse. But if I now make a change and add another data set, like another TIFF, it will say, okay, all the rest are already on the server, and we'll just update the addition, the delta of the project. And that is client-side publishing. You take your analyst, your city planner, your GIS user, they would use this editing tool, TerraExport. You remember that in the beginning we said that we have the editing tools of the scene. They added the scene and bring all the data from all the different components, and they just click Publish and perform what we refer to as client-side publishing. Even if you get an account on our Skyline Cloud, The way to get data onto the server is to connect from your computer to our cloud server, load the data from files on your disk, click publish, and it will find its way into our robust AWS implemented server-side solution where it can be served from to all your clients. Another quick way, or a quick way to get started, is actually on our knowledge base. We have a project, a demo project, the same one that I'm doing right now. So you can download and unzip this project and then click and publish it to your SkylineGlobe server. This is very useful as your first project. So before you start trying to publish your own data sets and maybe understanding Pro a bit better, this would be a very good first step to get something going. So you install the server and okay, now it's empty. It doesn't have any layers. How do I know it's working? So this is a very nice way. Also for all you sales reps out there that are listening to this webinar, this is a very nice way to get started. Also for when you install on-prem in an isolated network that does not have public internet access, come with this data set in your bag and do this immediately after you install SkylineGlobe server. So the SkylineGlobe server immediately has some data and can already, the data can be consumed from that server in Terra Explorer or even in Fusion, so in the browser on the client side. So we recommend using the sample project. Layers. Once you have published project, it's actually made out of many types of layers. Based on the layer type, it can have different information, like its geographic bounding box, its coordinate system, and some properties that are based on the type of data set. If it is, for example, feature layer, then you may want to decide how big of requests do you want to allow. So somebody doesn't go and take your data set for the entire California and try to consume all of it in one request, and then your server will end up sending gigabytes of data. So you can do special limitations that are specific to the type of layer. You can also limit the access, like we saw before from the right-click menu. So each layer has its own setting, and you can allow searching for it. You can change the layer properties. You can define its access permissions. You can delete, of course. There's like a recycle bin that allows deleting and then permanent deleting, and the layer categories that we talked about before that can be managed for the layers. Another, a little more advanced, but very good to know, is the way to update layers. So once I've created this project, right, in Terra Explorer, and I published it, and then I make an update version. There is a challenge in I just published my document, my project, and I sent URLs by emails or any other form to all my peers, and they connect to it. Now I want to update the version and make a little change, like add one layer, do some change, or anything like that. There's actually a very nice way that was introduced quite recently in the last version, I believe, to take a project, publish it, and then when you republish it, it will actually make another version of the same project in a way that the URL that was exposed would be updated. This is similar to how you load data or share your Word document on 365 or on Google Docs, and then share a link to anybody, and it becomes like a live shared canvas where you keep updating it, and each time people open that database, they get the recent or the most recent version of it, including a way to revert back to older versions if, for example, you made a mistake or something like that. So there's complete, it's not just that we have many layers, the project layers also have versions and history and a way to have people always connect to the same data. with the use of the update feature that we just saw here, and also another cool feature, which is called the alias. So let's say I have created data of Chicago and I published it, and now I have projects and people that are reading it inside QGIS or inside their ESRI client or their Explorer. Now, a year has passed, and I get a new database for my city, and I want to publish that, but all the other users are still pointing to the old URL. So now I need to send this information that the URL has updated. Instead, I can use an alias, which is take my layer and give it a name. Later on, when I get another version of the same data set, I will simply remove the alias from this layer and move it into the new layer. That name is used by the outside to connect to the layer. So if I update its alias, then it would always serve the current layer who's referenced by this alias. So these tools together are a bit on the advanced side, but just a bit. It really makes the publishing process much more streamlined in the way that you load the data, update it, and serve it consistently. That was the publishing. Now, interoperability. So we already said these are the services. We have terrain services, map services, feature, 3D mesh, point cloud, and so on. We know that. Each such service can be consumed by the different clients. So when I go to Air Explorer and I want to load a layer from SkylineGlobe server, you can see here the same dialogue that you saw from the SkylineGlobe Server Manager. When I can say, please find all data of type 3D layer and load it to my project. Okay. In a similar way, I can connect from an Esri or Cesium or QGIS clients. So this is the interoperability where I can take a whole bunch of different formats. The Terra Explorer Pro is the client, the editor, the publisher can read. It would do whatever it needs to convert and publish and essentially digest it and make it stream ready and do it in the part of the publishing. And then once consumed by the clients, it will get reprojected and converted on the fly as needed to the format of the different clients. And this is the support for different formats, and it will be streamed out and converted to the right format that is needed by the right client. Examples for that are given here, again, in knowledge base articles, showing you how to, for example, read data from SkylineGlobe server in your Unity or Unreal Engine and build a game out of that. And how cool is that? The fact that you can load data into a single place in a single format and be able to stream it to any type of client without needing to do any data duplication. So you can have old school users stream it into their Esri analyst station, and your kid building a game with it into the Unity engine or something like that. In a similar way, let's look at this, into Cesium clients. So there's a lot of Cesium-based viewers out there, and SkylineGlobe server is probably the best server to serve data into Cesium clients. By the way, also into the ESRI, the Esri clients, SkylineGlobe server is, and we get that all the time, that it's so efficient that people are amazed by it, and how it can do it without even natively being in the Esri formats. So same for QGIS and so on. And this is the interoperability. Optimizations. Let's talk about that. So we're moving into a bit more advanced side of things. For tips and guidelines, right? Let me click. Okay, tips and guidelines. So hardware considerations is a very important part. When I want to do my local portable SkylineGlobe server, I can just take a laptop and go out to field, and SkylineGlobe server would work on that. When I want to run it on-prem and serve dozens and hundreds and thousands of users, I need to be minded of the hardware specs that I have. The very basic requirements for software and hardware requirements are very basic. It's even a bit funny, like what we said, like 8 gigs of RAM and 4 cores. You can see I'm running the server off a very simple VM. However, when you go into the big boys game and you want to start seeing or taking into account what would be the right way to serve into big portions, I will show you in a bit how to size your hardware and everything on your IT side, the bandwidth, the disks, the I/O, to serve the number of users you expect and the number of traffic you expect to get. There's a bunch of tricks here in how to stream feature layers. Feature layers are actually tricky. When you have a raster layer, it's a regularly gridded data set. So all data is in the same resolution, and wherever you go to, it's the same amount of data. It's really very easy to stream. When you stream feature data, you can have, for example, a point layer, which is very dense in the area of a city, and then very sparse when you go to the rural areas. And to be able to stream that efficiently, there are some tricks mainly called the block width, like the quantas or the sizes of the requests that are made. And we recommend looking into this block width tool and this help in saying what is essentially the density of the data, and based on which what would be good geographical cubes or boxes or tiles to make requests for the data in. And this handles all that. I won't get into the details. Another thing is sometimes you have a feature layer with dozens of attributes because it's something, in your city, there's a planning, and for each manhole who created it and what's its weight and how many holes it have. But the end user of your community that is accessing this layer doesn't necessarily need to get all these attributes. If you selectively or intelligently decide which should be filtered out and used by the client, you can share or save some of the bandwidth and be much more efficient. We did not talk about a lot about direct connect. It's a bit more of an advanced topic, but if one can take the terrain database, like we see here, and again, VM, if I zoom out here, behind the mesh and the feature layers and the point clouds and all that, there's actually, you see a raster layer here of a higher area, of a bit lower resolution area, and all the way to a full globe. Now you can see there are parts in different resolutions, as I only have data inside this specific area in Frederick, Maryland. When you want to create a very big data set that is based from multiple meshes and multiple raster layers and multiple DTM, DSM elevation, you use a functionality called Direct Connect that streams the terrain service that we see over here, the terrain service, and or mosaics on the fly, different types of data sets. So you can build a data set of the entire US and have it built from fragments of a small data set for each state or even each county. And you build them individually and you collect them and mosaic them together using the TerraBuilder software. And then SkylineGlobe server will merge them on the fly. So if you update one county, you don't need to update the full terrain database. All you need to do is to open the editing software called TerraBuilder, remove the old county data, put the new county data in, save, and immediately when one flies on the data here in SkylineGlobe server, he will get the composed, merged mosaic database. So these are some direct connect optimizations that we want to talk about, and this is what was discussed here as well. To talk about hardware configurations, so as said, this document is very useful. It's accessible from the knowledge base as well. We have the basic functionalities and the basic requirements, but actually when we want to aim for redundancy, then we probably want more than one server. And so if one breaks, traffic would be automatically routed to the other. If we want to do scalability, like we discussed earlier, when traffic grows and there's an event in my city and all the community is suddenly hitting my server, I want to be able to launch more instances, more compute resources to account for the required traffic. So based on the user settings and based on what type of data and based on what caching I use, we actually have here in this document some numbers that not necessarily you, but maybe your IT people will say, okay, to stream when an average user flies to Frederick and looks at the downtown for the new proposal of a building, how much data does he consume? This gives you the guidelines. It will take about 8 kilobytes per block, and it will take about 15 blocks per second of flying on average on many users, because some of them already have the data cached and so on. And then you can extrapolate linearly and know if I want to support 500 users, this is the bandwidth I need. If I want to support 1,000 users, this is the disk I need. This is the network I need, and so on. So this is a very useful document, and we, with a case study, and we recommend looking at it and extend the recommendation to contact us at support@skylinesoft.com, and we will help you in gauging that. So that would be the optimizations. So we will resume with the advanced topics. Again, we will go over some of the topics that we have touched earlier and expand about them. The first one we wanted to go over is the installation of which operating system. The default one and also the main one that SkylineGlobe server has been served onto over the years is on Windows Server. And in this example, we've used Windows Server 2022 to install it. But SkylineGlobe server can also run on a Linux machine. Currently, it requires some steps installation. This looks a bit scripty, but it's not very straightforward to run. Essentially, the nice thing about it, also on the Linux and also on what is called SkylineGlobe Server Edge, is that we have the components to run it as without installation. So both on Linux and on Windows Edge, we just simply have an executable, just like Notepad or something, that you just run the executable and that launches your server. You go to the command line, you run CMD, and you select, I want to run this and that executable, like we see in this example. And it will start a SkylineGlobe server. So without needing to take an operating system and make sure your IT does whatever is needed there, and then installs IIS for you, and IIS has its own management know-how and so on. With these, both on the edge on Windows and with the edge on Linux, you can just take a simple software. Essentially, all this does is put some dependencies in the operating system, extracts the file from the zip, and simply runs it. And once you run it, you can access the server. And when you stop the service, it stops, and you don't need anything more complicated than that. It is pretty straightforward to run. The more complicated steps is how to run it in a cluster that we will touch in a second. We will put here already that by the time you may be hearing this, we're actually moving this to a different technology in the next version that will be based on .NET Core, making some of these steps similar but more simple. But the principles would be the same. You take a computer, whether Linux, whether Windows, it can be inside a Docker, it can be running in your Kubernetes environment, and running this process would simply give you the same SkylineGlobe server as I got from here by running a simple executable either on Linux or on Windows. Since we have touched this a bit, I will talk about the clusters before I go to the security settings. The cluster is the following. When we installed SkylineGlobe server, I showed you how I do a simple standalone installation by creating a new database, which created a small file on my disk. This gives me one computer that can be accessed, and then if it fails, if it updates Windows or anything else, I have downtime. If I have many users accessing it at the same time, then the server is saturated and they don't get served fast enough. The concept of a cluster is that there are multiple computers, but they are equal, identical twins, meaning I can have 1, 2, or 20 servers, physical computers or instances or Kubernetes pods, doesn't really matter. And they all share the same database, making them identical, meaning that instead of creating a new database, I will choose an existing database, or on the first computer in the cluster that I install, I will create a new database, and instead of putting it on my C drive, I will put it on some shared storage, so a UNC path / my server / SkylineGlobe server database. Next, I will install it in the exact same way. When I go to the next server and install SkylineGlobe server, or when I clone the server, I simply tell it, choose an existing database, and then computer A and B will both be connecting to the same server-side storage, server-side database. So all the information that we add in here, like the sites and the layers and the users and all that, is actually stored inside this configuration database over here. If this configuration database is accessible to all the different computers, then they are all the same. And if one user, and normally this comes with a load balancer, that is the front end when all clients connect to. The load balancer distributes each user to one of the available computers, servers. Again, they are all identical servers. Each of them knows how to serve any of the layers to any of the users. And if a user connects to one of these servers and publishes data, the database is updated and all the servers are aware of it. And from a commercial point of view, also worthwhile mentioning, that when we license and price SkylineGlobe server, it goes by the number of concurrent users. So we sell SkylineGlobe server with 10, 50, 100, 1,000 users. And this is the price. And it doesn't matter to us whether you serve 100 users from one computer, two computer, or five. This is completely up to you because the server cluster shares also the licensing information, meaning if one computer in the cluster has the license, then the rest will just work. And if you want to serve that 1,000 user license by 10 computers, or you want to scale up in times of high bandwidth to 20 computers, you can do it dynamically and grow dynamically in AWS and cloud environments as a concept of an auto-scaling group. And that cloud system could do the service for you in launching and stopping computers based on the stress, based on the need. But SkylineGlobe server itself is built to work in this cluster environment in a way that you configure it only once, and you all the computers, just like I had one, if I now clone it, would share the same database, so they serve as identical twins, clone twins. The way to do it that I showed you here, by setting the database to a file on a shared storage, is good to a certain extent. But since the database here is a file-based database, that can only take you so much. This is strictly from an IT and configuration point of view. So if you want to take it to the next level, you will replace this file-based database, either local or on shared storage, with this next level, which is storing the same management database instead of the file-based database that we saw before that we installed on the simple flow. You install it with Postgres SQL, and that would be a managed or non-managed database that somebody manages, has its own backups. It itself can be made of multiple computers. That could be your database guy who already has a database and will just tell you, here's the connection, connect to it and store it there. Or if you're in AWS or Azure world, you can get a managed server, and then you don't need to worry about the failovers or single point of failure of your database because you host it on a robust organizational database. So this is what I wanted to say about these actually come together. The Linux or Edge, which are running on multiple computers without installations, that can be grouped together in a cluster, which all it means to be a cluster is that it's multiple computers that are connected to the same database, and thus they serve as identical copies. And because the requests for SkylineGlobe server are what is called stateless, it means that every request that the client makes is independent. So even if the load balancer sends my request number 1 to server A and my request number 2 to server B, it doesn't matter which server I end up against, they would serve the response for that specific request, and I would get what I need. So even if a server fails or goes into maintenance and the load balancer redirects me to another server in the cluster, it will go completely seamlessly. So this handles the failover and elasticity, redundancy, and so over. So these group of stars advanced topics go together. The next topic I want to talk about is the security. The security has become actually a bit more demanding in the latest versions of SkylineGlobe server because of TerraXplorer Fusion, which is a very high or highly technical solution that is running inside the browser. So you don't often find a web page that can show such a rich, performant 3D window with all the functionalities you used to get on desktop software before inside your browser. This calls for some security settings that the browser enforces on running Internet Explorer Fusion and on connecting to SkylineGlobe server. On a simple flow, you have your IT guy, or you have the people that manage your network, and all you need to do is to tell them, I want to have a secured site. You notice how every site I go to in the real internet is HTTPS because it has a certificate, and somewhere where we publish our database and our knowledge base or our site, we go and purchase a certificate that tells the pages coming from skylinesoft.com are okay. There is a way to do it in any organization that is called a certificate. To give that certificate, one could, on public internet, again, contact what is called certificate agencies or authorities and get an approval that identify this is Skyline Software Inc. They're okay. They paid a certain amount of money for that and got a certificate. On other organizations like different types of closed organizations, security organizations, and so on, they have their own different set of certificates. How does one add certificate to the SkylineGlobe server? In many cases, the answer is in a completely transparent way. Meaning, currently, remember, I have my SkylineGlobe server here on a non-secure. This is an HTTP. It's not an HTTPS. In many cases, the servers inside would still be HTTPS and some wrapping layer in form of a proxy or a load balancer or WAF, some kind of firewall, would add another access layer on top of your SkylineGlobe server. And you would go to your IT person and say, I have a server in this internal address. And he would say, okay, no problem. This is now exposed as https.lasvegas.com. Because the guy from Las Vegas knows that if you go to lasvegas.com/sg, he will route it to your internal HTTP. So you don't really need to worry about that. You just need to find that person that knows how to expose SkylineGlobe server as an HTTPS, and you don't need to do any change on your side other than going to the settings here and telling it from now on, when I'm accessed from the outside, I'm not accessed as HTTP my internal IP, but HTTP www.skylinesoft.com, HTTP www.mycity.com. So this is like the first requirement for HTTPS or the first implementation. So in many cases, when you go into the organization, when you deploy SkylineGlobe server in your organization, go to your IT guy and say, how can I access the same HTTP site as HTTPS? And that will allow people to connect securely to SkylineGlobe server and also for Internet Explorer Fusion to work smoothly inside the browsers, because otherwise the browser would not allow Fusion to run because it is such a advanced process that is otherwise blocked. What do you do if you can't do that? And if you don't have like the IT resources to provide for it, then we have here in our knowledge base, I think I prepared it somewhere, but let's just go here and say yes. Okay. So configure SkylineGlobe server for Internet Explorer Fusion over unsecured networks. This is explains all the ways to get a certificate. This is the trusted environment, like get it from a certification authority. And it also lists how to create a self-signed certificate. A self-signed certificate is essentially, normally how certificates work is that when I go as SkylineSoft to the certificate authority like VeriSign, and I tell them I'm Skyline Software Systems, please issue security certificate for me, then they go and they put in the security information that says exactly, I don't know if I can access it from here, let's see. Yeah, so this is Skyline Soft, and so-and-so approved it, very signed, some blah, blah, blah. When you do it inside your own organization, you can create a certificate that is not accepted by anyone. It's not authorized by another level of security, but it will be good enough for clients inside the computers, inside the network, that say, okay, I'm willing to trust that certificate to allow it to access it securely. This here lists the steps of how within IIS, but there's also other ways to do it, to very easily create what is called a self-signed certificate. It takes 3 scrolls, but it's not a lot to do. And then one could access the data securely also with Fusion by installing this self-signed certificate. This would be a good solution for deploying SkylineGlobe servers in closed environments that do not have the full IT scope. We have like a landscape or an architectural firm that installs SkylineGlobe server for its local 10 users. Everybody that accesses it are people from within the organization, the architects. We don't really need full validated pay-for security. We just put this self-signed certificate and people are ready to use it very easily. Another way, which is the least secured, is if you install and accesses the site just from the same computer, just like I have here on my VM. So inside my VM, you remember I'm accessing the SkylineGlobe server using this address, 127.0.0.1. This is the loopback address. On any computer that you go to, if you type 127.0.0.1, it will actually go internally to the same computer, either that or you use the term localhost. This is something built into all OSs. Okay, to log out and log back in. But in any case, you see it goes to the SkylineGlobe server. And the sense, what we said that the security enforcement is for not running Fusion, which uses a technology called WebAssembly from a non-secured side. If it's if it's the local address, it will let you, because it said you're using your own computer and you're consuming the server that you've installed locally from within the same computer. You probably know what you're doing. So this would be good enough for a completely standalone server, just like I did here. I didn't use any certificate. I just installed it on 127, and I can go ahead and again, this is VM. But if I go here, I can actually open inside my web from a non-secured address the TerraXplore Fusion and load the same project that I have published before. I won't necessarily wait for it right now. So this article really talks about the different ways, the different approaches, the best one, the right one, the least one just for development for a local computer, and the middle one with a self-signed certificate. There are few more gray shades here. Some organizations would have other types of certificates, and as long as they're approved by that organization or by the client machine, it will let you consume SkylineGlobe server. It could be a bit of an issue, and this is why you would see sometimes that when you connect to the client on computers that do not satisfy the security requirements, you would get certain errors like this shared array buffer. And this actually lists some of the steps that you could do to allow accessing it. Again, this is a topic for a webinar of its own, but just so you know, First, don't panic about it. It's easy to do. Keep in mind that when you install SkylineGlobe Server, you need to be minded of how people are connecting to it, whether by HTTPS or by unsecured. The last topic that I'm really going to brush over is the API. SkylineGlobe Server has an API, pretty basic one that allows users or allows different types of automations and system to integrate into SkylineGlobe Server. You see, it allows you to create group, create users, and so on. And this also, as we discussed before, if I'm integrating SkylineGlobe Server into my organization, and we discussed the fact that SkylineGlobe Server can connect to your own single sign-on or IDP, then you could tell SkylineGlobe Server that instead of managing its own user system that we saw before, it can use your IDP, your identity provider, your organizational 365, or your organizational Cognito, or your Google account, your Office Google account, G Suite account, and it will allow you to not need to define users, but simply any user that is part of my Office 365 account would automatically get a user inside SkylineGlobe Server by connecting the two systems. So when I go to adobe.com, because Skyline has purchased an account there, I can log into Skyline's Adobe account using my Office 365 credentials that we have in Skyline. In a similar way, you connect SkylineGlobe Server to your IDP, and then every user within the city council that already have a username and password would simply access SkylineGlobe Server using the same credentials, and you don't need to define it. These APIs support this functionality without going too deep into that. So these were pretty much the advanced topics we wanted to cover. To summarize a bit about what we discussed today before we gonna wrap this recording, we talked about what is SkylineGlobe Server. We covered the foundation of how to install, configure, and manage. We talked about using. So I'm a user. I don't know how to install SkylineGlobe Server or configure it, but I work against it, mainly by publishing layers to it and consuming data from it, from Terra Explorer and other open source and proprietary tools. And then we've covered some of the advanced topics. This is really in a nutshell. Each such advanced topic has more to talk about, but in this level, I think it would suffice. There's resources and there's help in supportskylinesoft.com that could help you explore and expand these topics a bit more. And thank you very much.